At 2:47 in the morning on March 14th, 12 Iranian ballistic missiles entered Israeli airspace. They were detected immediately. Every radar system positioned around Ben Gurion International Airport was operational. Every Iron Dome battery was staffed, powered, and ready. The engagement sequence that has intercepted thousands of rockets, missiles, and mortar rounds over the past decade initiated exactly as it was designed to. 31 interceptors launched. 2 minutes later, Israel's only international airport was no longer functional. Not one missile had been stopped. What happened in those 2 minutes was not simply an attack on an airport. It was the public demonstration of something that defense engineers, military planners, and intelligence analysts in Washington, Moscow, Beijing, and Tel Aviv had been quietly calculating for years. The moment when a purpose-built counter-system met the world's most battle-tested missile defense architecture in real combat conditions and defeated it completely. To understand why those 31 interceptors failed, you need to understand what Iron Dome was built to do, what it was never designed to handle, and how Iran spent years engineering a weapon that sat precisely at the boundary between those two conditions. And to understand why this moment changes warfare beyond this conflict, beyond this region, and beyond this decade, you need to follow the logic from the airport aprons, where 73 aircraft are still burning, all the way to the defense procurement offices in every major military capital on the planet, where the same conversation is now happening behind closed doors. That conversation started the moment those 12 missiles landed. Part 1. What Iron Dome actually is. Iron Dome entered operational service with the Israeli Defense Forces in April 2011. Within a month of deployment, it intercepted its first rocket fired from Gaza. By the time of Operation Pillar of Defense in November 2012, it was achieving intercept rates that defense analysts described as historically unprecedented for a battlefield missile defense system, rates above 80% against rockets and short-range ballistic threats. The system's architecture is built around 3 core components. The detection and tracking radar, designated ELM-2084, scans a 360-degree coverage zone continuously, identifying incoming projectiles, calculating their ballistic trajectories, and projecting their impact points within seconds of detection. The system then performs a calculation that is central to its operational logic. It determines whether the projected impact point represents a threat to populated areas or critical infrastructure. If the projected impact is open ground, the system does not engage. It conserves interceptors for threats that matter. The second component is the battle management and weapons control system, the computational architecture that takes the radar's data, confirms threat classification, calculates intercept solutions, and directs the third component, the Tamir interceptor missiles, to their engagement windows. The Tamir interceptor is a small, maneuverable missile equipped with a proximity fuse and electro-optical sensors. It doesn't need to physically collide with an incoming rocket. It detonates close enough to destroy or destabilize the threat through blast fragmentation. In the dense, chaotic incoming fire of a Gaza conflict, dozens of unguided rockets fired in irregular sequences, the Tamir performs with remarkable reliability. That reliability built Iron Dome's global reputation. By 2023, Israel had deployed 10 operational batteries. The United States Army had purchased 2 batteries for its own use. South Korea, India, and multiple NATO-adjacent countries were in various stages of acquisition discussions or technology transfer agreements. Iron Dome was not just Israel's defense system, it had become the global benchmark for short to medium-range missile defense. 3 batteries were positioned around Ben Gurion International Airport on the night of March 13th. Fully operational, fully staffed, radar active, interceptors loaded. And when 12 missiles came, all 31 interceptors fired, and none of them succeeded. To understand why, you have to understand the specific nature of what those 12 missiles were carrying. Part 2. The engineering of defeat. The K-bar Shakan 4 is not a new weapon system. Iran has been developing its ballistic missile program for decades, and the Shakan series represents the mature expression of that development. Solid-fueled, road-mobile, GPS-guided ballistic missiles with ranges covering the entirety of Israel and most of the broader Middle East. Against a point defense system like Iron Dome, a standard ballistic missile, even a sophisticated one, presents a manageable engagement problem. It follows a predictable trajectory. It carries a single warhead. The radar detects it. The battle management system calculates the intercept solution. The Tamir launches and closes on a trajectory that intersects the incoming missile before it reaches its target. The system was built for exactly this scenario, and it handles it reliably. The Shikan 4's designers understood this, and they built a warhead specifically engineered to transform that manageable problem into an unmanageable one at the moment it matters most. The K-bar variant carries a cluster munition warhead. The casing is designed to open at a specific altitude during terminal descent, high enough that the sub-munitions have time to disperse and orient, low enough that the defense system's remaining engagement window is severely compressed. When the casing opens, each missile deploys 10 sub-munitions, independent, GPS-guided, equipped with control fins that allow maneuvering during descent, breaking the predictable ballistic trajectory that the intercept algorithm depends on. 12 missiles became 120 independent maneuvering targets in the span of seconds. The Iron Dome's battle management system now faced a computational problem it was not architected to solve. Generating an intercept solution for a single incoming warhead requires the system to calculate a closing trajectory, confirm threat classification, assign an interceptor, and execute the launch sequence. That process happens fast, but it has a finite processing capacity. There is a ceiling to how many simultaneous engagement solutions the system can generate and execute within a given time window. 120 maneuvering sub-munitions arriving simultaneously from multiple approach vectors, the Shikan 4s were not fired from a single direction. They approached Ben Gurion from several different angles, exceeded that ceiling by a factor that made successful intercept mathematically impossible given the system's current architecture. The Tamir interceptors that launched were not misdirected. They were not malfunctioning. The system was doing exactly what it was designed to do. It simply could not generate and execute 120 intercept solutions in the seconds available before the submunitions reached their target zones. Not one interception succeeded. The submunitions struck the runways, the terminal, the fuel storage facilities, the aircraft parking areas, and the air traffic control tower with a distribution pattern that the IRGC described in its post-attack statement as designed to produce maximum operational disruption and maximum economic damage. On both counts, the objective was achieved with a precision that exceeded even optimistic Iranian planning assessments. Part 3. What burned to understand the scale of what was destroyed at Ben Gurion in those 2 minutes? You have to understand what Ben Gurion actually represented to the Israeli economy, because this was not a military installation. It was the physical node through which Israel participated in the global economy. 20 million passengers annually. The overwhelming majority of Israel's international cargo operations, medical supply chains, technology component flows. Israel is a significant node in global semiconductor and defense electronics supply chains, and those components move by air. Foreign direct investment logistics, emergency supply routing, military transport operations dependent on civilian air infrastructure. Tourism revenue running at approximately $450 million per week. Business travel, the movement of executives, investors, and deal makers who physically come to Israel to commit capital. All of it ran through one facility. Israel has 2 other airports, Haifa and Eilat. Both have runway infrastructure, both handle domestic and some regional traffic, but neither can accommodate wide-body international aircraft. Boeing 787 Dreamliners, Airbus A350s, Boeing 777s, the aircraft that carry the passenger and cargo volumes that make international connectivity economically meaningful, cannot land at either facility. The runways are too short. The ground infrastructure doesn't exist. For international operations at scale, Ben Gurion was the only option. That geographic and infrastructural reality is what made it a target of this strategic category. Iran did not destroy one of several options. It destroyed the only option. The aircraft losses tell the story of the physical destruction with a clarity that the infrastructure damage alone does not fully convey. El Al, Israel's national carrier, had 23 wide-body aircraft on the ground at the time of the strike. These were Boeing 787 Dreamliners and Boeing 777s, aircraft valued at approximately $250 to $350 million each, depending on configuration and age. 23 aircraft at an average replacement value of $300 million represents approximately $6.9 billion in losses for El Al alone. But the financial damage is considerably larger than the replacement value of the aircraft, because those 23 planes constituted essentially the entirety of El Al's long-haul international fleet. The airline has not lost aircraft it can replace while continuing to operate on reduced capacity. It has lost its capacity to operate internationally at all. The distinction matters enormously for what happens next to the airline. Foreign carriers suffered parallel losses. United Airlines had 7 Boeing 787s on the ground, having arrived for overnight turnarounds before scheduled morning departures. Lufthansa had 5 Airbus A350s, Delta had 4 Boeing 777s, British Airways had 3 Airbus A380s, the largest commercial passenger aircraft in service, each valued at approximately $450 million. Air France, KLM, Turkish Airlines and Emirates had a combined 12 additional aircraft parked at Ben Gurion. When the missiles struck the aircraft parking areas, the fuel tanks ignited. Wide-body aircraft carry tens of thousands of gallons of aviation fuel. A Boeing 777 on a full fuel load carries over 140,000 kilograms of jet fuel. When that fuel burns, it burns at temperatures exceeding 1,000 degrees Celsius. Aircraft structures melt. Everything inside the airframe is consumed. By the time fire crews could respond, the aircraft were total losses. The Israeli Air Force additionally lost 19 military aircraft stationed in a section of Ben Gurion used for logistics and military transport operations, F-15s undergoing maintenance cycles, C-130 Hercules transport aircraft, and smaller military planes used for reconnaissance and communication support. Those losses degrade Israel's air transport capacity and reduce the number of airframes available for combat operations at a moment when that capacity was already under sustained pressure from 15 days of continuous conflict. Total aircraft destroyed, 73. Total estimated replacement value, $12 to $15 billion. That is the largest single-event destruction of aircraft since September 11, 2001, when the grounding of the American civilian fleet created losses of a different nature but comparable financial magnitude. Beyond the aircraft themselves, the physical infrastructure damage sets a repair timeline that defines the economic disruption window. The 4 runway craters, 15 meters wide, 5 meters deep, require excavation down to the substrate, installation of reinforcing materials, and repaving with reinforced concrete capable of bearing the load of fully fueled wide-body aircraft. This is not a patch operation. The structural integrity requirements for a runway bearing a Boeing 777 at maximum takeoff weight are significantly more demanding than road repair. Runway restoration alone will take 4 to 6 months under optimal conditions. Optimal meaning no further attacks, no supply chain disruptions, continuous round-the-clock work crews. Terminal 3 sustained structural collapse when 2 missiles struck the building. The preliminary engineering assessment indicates the terminal will likely need to be demolished entirely before reconstruction can begin. A 12 to 18-month project that cannot begin until the demolition is complete and the site is cleared. The 73 aircraft wreckages on the aprons and taxiways must be removed before normal ground operations can resume. Burned wide-body aircraft cannot simply be towed away. They must be cut into sections using industrial equipment and removed piece by piece. That process for 73 aircraft across multiple impact zones will take 2 to 3 months. The fuel tank strikes created an environmental contamination problem that adds additional time to the restoration timeline. Aviation fuel has soaked into the ground across sections of the airport, requiring environmental remediation before those areas areas can be safely used for aircraft operations or ground crew work. That remediation process adds another 3 to 4 months. The optimistic estimate for reopening Ben Gurion to commercial operations is September 2026. The realistic estimate, accounting for likely delays, supply chain constraints, and the complexity of simultaneous reconstruction across multiple damage zones, is January 2027. Israel will be without a functioning international airport for a minimum of 6 months and potentially up to 10. Part 4. The insurance architecture of paralysis. The physical damage at Ben Gurion is severe. The repair timeline is long, but there is a dimension of this attack's consequences that will outlast the physical damage and potentially outlast the repair timeline itself, and it operates through a mechanism most people don't think about when they think about military strikes on civilian infrastructure. Aviation insurance. The global aviation insurance market operates on a foundational actuarial assumption. Catastrophic events at major international airports are statistically rare. The premium structures, the coverage terms, the reinsurance arrangements that underpin the entire system, all of it is built around the statistical rarity of events, like what happened at Ben Gurion on March 14th. A single attack that destroys 73 aircraft at one facility in under 2 minutes is not statistically rare anymore. It is a demonstrated and documented threat, and when an insurance market recalibrates its risk model in response to a demonstrated threat, the effects move faster than any physical reconstruction. Within hours of the attack, major aviation insurers were already communicating with their clients, the airlines, the airport operators, the aircraft leasing companies, about what coverage would look like going forward for operations at Ben Gurion. The signals from that communication are unambiguous. Coverage will not be provided for aircraft operations at Ben Gurion unless Israel can demonstrate reliable protection against the ballistic missile threat that just destroyed 73 aircraft in 2 minutes. Israel cannot currently demonstrate that. The Iron Dome failed completely. Netanyahu's public statement 4 hours after the attack, "We cannot guarantee it will not be hit again," is not the kind of statement that reassures an insurance underwriter. It is the kind of statement that ends the underwriting conversation entirely. El Al faces an insurance claim in the range of $8 to $12 billion for its destroyed fleet, potentially the largest single aviation insurance payout in history. The insurers covering El Al are already signaling that they will not renew policies for replacement aircraft operating from Ben Gurion under current conditions. That means, even if El Al had the financial resources and the access to capital markets necessary to purchase new aircraft, which, facing a claim of this magnitude, while simultaneously losing all international revenue, is itself deeply uncertain, it could not insure those aircraft for operations from its home airport. Without insurance, the airline cannot operate. It's not a choice. Commercial aviation requires hull insurance and liability coverage to function legally in virtually every jurisdiction. An uninsured wide-body aircraft cannot take off. Foreign airlines face the same calculation. The insurers who just paid billions in claims for aircraft destroyed at Ben Gurion are telling those same airlines that future operations at Ben Gurion are uninsurable at commercially viable premium levels until the security situation changes fundamentally. Commercially viable is the key phrase. Coverage might technically be available at premium levels so high that the economics of operating the route become impossible. The practical effect is the same as no coverage at all. The consequence is a scenario that no amount of physical reconstruction solves on its own. Ben Gurion can be repaired, runways repoured, terminal rebuilt, aprons cleared, fuel systems restored. The facility can be physically restored to full operational capability by January 2027 or whenever the reconstruction is complete, and it can sit largely empty. Because the airlines that used to fly there cannot obtain insurance to return, and without airline operations, an international airport is an expensive concrete infrastructure with no economic function. Netanyahu understood this when he made his statement. The advisors around him understood it. The question of whether Israel can defend Ben Gurion against future attack is not simply a military question. It is the question on which the entire economic case for international air connectivity rests, and he answered it honestly. We cannot guarantee it will not be hit again. Part 5. The tactical logic. The IDF's preliminary assessment of why the Iron Dome failed at Ben Gurion, which was shared with defense attaches from allied nations within 24 hours of the attack, identified the specific mechanisms of the defensive failure with a candor that reflects both the severity of the situation and the strategic value of understanding it accurately. The Shikan 4's multi-vector approach was the first element. The 12 missiles did not approach Ben Gurion from a single direction. They approached from several different vectors simultaneously, a firing pattern that requires multiple launch platforms positioned at different geographic locations, and that was clearly coordinated to present the defensive system with simultaneous threats arriving from different approach angles. Iron Dome's engagement geometry is optimized for threats approaching from a limited number of vectors. When threats arrive simultaneously from multiple directions, the system must manage intercept geometries across different approach angles at the same time, increasing the computational and physical demands on both the battle management system and the interceptor inventory. The cluster munition deployment altitude was the second element. The Shikan 4 warhead is designed to open at an altitude that represents a calculated balance between two competing requirements, high enough that the submunitions have time to disperse, orient their guidance systems, and establish stable descent trajectories, but low enough that Iron Dome's remaining engagement window after the warhead opens is severely compressed. The system detects the incoming missile. It begins calculating an intercept solution. Then the warhead opens, and the missile becomes 10 submunitions. The system must now recalculate, not one intercept solution but 10, for targets that are now maneuvering, now dispersed, and now significantly closer to the target zone than the original missile was when first detected. The time available to execute those intercept solutions is a fraction of what it would be if the warhead had opened at higher altitude. The submunition maneuverability was the third element. The control fins and GPS guidance on each submunition mean that they do not follow the predictable ballistic descent curve that Iron Dome's intercept algorithm is built around. A ballistic projectile follows a trajectory that can be mathematically projected forward. The system calculates where the projectile will be at a future moment and sends the interceptor to that point. A maneuvering submunition can alter its trajectory after that calculation is made, potentially invalidating the intercept solution before the Tamir reaches the engagement point. And the volume was the fourth and decisive element. 120 independent maneuvering targets arriving simultaneously from multiple vectors at an altitude that compresses the remaining engagement window with trajectories that resist projection. The combination exceeded Iron Dome's processing and engagement capacity by a margin that made successful intercept of the full incoming salvo impossible, regardless of the system's individual component performance. The IDF assessment used carefully precise language. It did not describe the failure as a malfunction. It described it as the system performing within its design parameters against a threat that exceeded those parameters. That distinction matters because it means the solution is not fixing something that broke. The solution is building something different, a defensive architecture that addresses the cluster munition submunition problem at the level of system design rather than trying to upgrade the processing speed of an existing architecture that was never designed for this threat volume. Part 6. The Global Defense Calculation. The conversation that began in defense ministries around the world within hours of the Ben Gurion attack is the most strategically significant consequence of the strike, more significant in some respects than the physical damage to the airport itself. Because the K-Bar Shikan 4's performance at Ben Gurion was not just an Israeli problem. It was a demonstration that every country currently relying on Iron Dome-style point defense architecture for critical infrastructure protection had to evaluate against its own threat environment. The United States Army operates 2 Iron Dome batteries. Those batteries are positioned to protect specific high-value assets, the same defensive logic that placed 3 batteries around Ben Gurion. The Army's assessment teams were analyzing the Ben Gurion engagement data within hours of the attack, running the same calculation that the IDF was running. If 12 Shikan 4s with cluster warheads can defeat 3 fully operational Iron Dome batteries, what does the Army's current point defense posture look like against an adversary with access to equivalent or superior cluster munition ballistic missile technology? South Korea, which has invested heavily in layered missile defense architecture, including Iron Dome components, was running a parallel analysis focused on the North Korean ballistic missile inventory, which includes cluster munition warhead variants. India, which had been in advanced discussions about Iron Dome acquisition, was reassessing the strategic value of that investment given the Ben Gurion performance data. The recognition is this: single-layer point defense against cluster munition ballistic missiles is not a viable defensive posture for high-value fixed infrastructure. The Ben Gurion engagement proved it in combat conditions against a real target with real consequences, in a way that no simulation or war game had previously been able to demonstrate with equivalent authority. The defensive architecture that addresses this problem requires multiple engagement layers operating at different altitudes and phases of the incoming missile's trajectory. You need systems capable of engaging the ballistic missile before warhead deployment in its boost phase or early terminal phase, before the cluster munition casing opens and the volume problem emerges. The Israeli Arrow system and the American THAAD are designed for this engagement envelope, but they were not positioned around Ben Gurion in the numbers that would have been required to intercept 12 incoming missiles before warhead deployment, and their interceptor costs, several $1 million per round, create their own strategic and economic constraints when facing a high-volume salvo attack. You also need processing architecture that can manage the post-deployment submunition problem, a system with sufficient computational capacity and interceptor inventory to address the volume that cluster munition warheads generate. No currently deployed system anywhere in the world meets that requirement at the scale demonstrated to be necessary by the Ben Gurion attack, which means the gap between current deployed defensive capability and the demonstrated offensive threat is real, it is large, and it will take years and billions of dollars to close. Iran knows this. The IRGC's targeting team knew it when they selected Ben Gurion as the target for the Shikan 4's first major operational employment. They selected a target protected by the world's most battle-tested point defense missile system in front of the entire international defense community to demonstrate the limits of that system against a purpose-built counter. The demonstration succeeded completely. Part 7. The strategic architecture of the attack. Understanding what happened at Ben Gurion requires separating two questions that are often conflated in military analysis. The first question is tactical. How did the missiles get through? That question has the engineering answer described above: cluster munition warheads, multi-vector approach, submunition maneuverability, volume exceeding defensive processing capacity. The second question is strategic. Why was Ben Gurion the target? Why not an IDF airbase? Why not a military logistics facility? Why not a headquarters complex or a command and control node? The answer to the second question reveals the full depth of the operational planning behind the attack. Israel has been in active military conflict for 15 days. Its military infrastructure has been under continuous pressure. The IDF is conducting strike operations against Iran while simultaneously defending against Iranian strikes, a two-front operational demand that strains both personnel and equipment. But Israel's military capacity, while under pressure, remains functional. The IDF is still flying missions, naval assets are still operating, ground forces are still positioned, military infrastructure, built and defended with the assumption of being targeted, has absorbed damage and continued functioning. Ben Gurion was not military infrastructure, it was economic infrastructure. And it was economic infrastructure with a specific property that military infrastructure does not share. It is irreplaceable on a short timeline. A military airbase can be partially repaired and returned to limited operations within days or weeks. Hardened military facilities are designed with redundancy and damage resistance. A major international airport with its runway geometry, its terminal infrastructure, its fuel systems, its air traffic control architecture, its cargo handling facilities cannot be patched back to operational status. It requires a reconstruction timeline measured in months to years.